In this video, we're going to talk about something called energy pyramids. So energy pyramids aren't that different than the food chains that we've already looked at. So you might have something as simple as this. You might have a leaf, and that leaf is getting eaten by, say, a mouse. And then you have that mouse getting eaten by something like a hawk. And the important thing to remember is that this diagram is showing us the flow of energy. So our plant here has captured the energy from the sun through a process called photosynthesis. And that plant is making sugar. And sugar is the source of energy for all living things on the planet. So this leaf is getting its energy from the sun, storing it in the form of sugar, and that sugar is traveling up the food chain. But what we're going to learn is that not all of the energy that's, say, in our leaf ends up in our mouse, and not all the energy that's in our mouse ends up in the hawk. And that's because every organism in the food chain is using a little bit of energy. So let's take a look at what that looks like. Let's just start off with our mouse here. Let me draw our little mouse. So our mouse is going ahead and he's eating up the leaves. There's a little leaf. And every time that mouse eats the leaf, he's getting the energy from the leaf. But what happens is that mouse is doing all sorts of things. He's running around, he's hopping through the forest. So as he runs around and does all what he does, he's using some of that energy. And when he uses that energy, he actually takes it and he transforms it into heat. And this is why organisms give off body heat. And so as this energy is being taken in from the leaf, the mouse is eating it, he's storing some of it, but most of it he's using and he's giving off as heat. What actually ends up happening, and this is kind of like just a ballpark figure, but the mouse himself takes in 100% of the energy from the leaf, and he uses about 90% of it. So 90% of that energy that mouse took in from that leaf, he's using and turning into heat. What happens is the other 10% of that energy from the leaf is going off to our hawk. It's the best hawk I could do. So even though the mouse ate 100%, only 10% of it gets carried on to the next step in the food chain. That 90% that the mouse turns into heat, unfortunately no organism on the planet can use heat as a source of energy. So what ends up happening is that heat gets lost and it ends up going into outer space actually. And so the Earth is actually giving off heat into outer space because all the organisms on the planet are really hot, they're producing heat, and the heat just flows off into space. So only 10% of it ends up going into the next step, into the food chain. So let's take a look at kind of how that works in our food chain. Let's say we have a simple food chain that goes tree, deer, bear. Our tree, we could say, is going to start off with 100% of the energy. Because again, our plants are making all that energy usable in the form of sugar, so they're the main source of that energy. Only 10% of that is going to go and get passed on to our deer. At every step in the food chain, we're going to lose 90%. So only 10% of the original amount of energy is going to make it to the deer. And then if we go a step further, only 10% of that 10%, or we could say 1% of the original amount of energy, is going to make it off to our bear at the top of the food chain. And so we're going to do some simple math with this, but first you need to know about energy. So if you've ever looked at the back of a label of food, you might have seen something called a calorie. A calorie is just a measure of energy, and we actually measure it in heat. It's the amount of heat required to raise 1 gram of water by 1 degree Celsius. So basically, the more calories you have, the more water you can heat up. And scientists actually do this. They take a piece of food and they light it on fire and they measure how much heat that food is giving off with a thermometer. They literally take your Cheetos and light it on fire. So these energy measured in calories here, we can measure that in our food. If we took say we take a simple food chain again, we take the tree, and let's say, for example, our tree has done a lot of work. He's been capturing energy all day. He might, produce, let's say, let's just make up a number, 6,000 calories of energy. And so let's say along comes our deer and eats that tree. He's only going to get 10% of that 6,000 calories. So 10% of 6,000 is 600. So that deer is only going to get 600 calories from the plant. And then if we go the next food level up and say we look at, let's say it's our bear again. Our bear might go around and eat the deer, and he's only going to get 10% of that, so he's going to get 60 calories. And again, these are made up numbers. Obviously, a bear cannot live on 60 calories. But it's just an example of 10%, 10%, 10% going down our food chain here. And keep in mind that when we talk about these 10%, we're talking about it for all the trees in the forest, all the deer in the forest, and all the bears in the forest. So when we measure these calories, we're measuring, well, what's the total amount of calories in all the deer in the forest? So we're going to look at this, and we're going to look at it in the form of a pyramid. So if I were to actually just draw a simple pyramid here, this is a perfect representation of calories in a food chain. So what we have at the bottom, let's say it's our 6,000 calories, and we could say that those belong to whatever plants we're looking at. Maybe they're trees. And then if I go the next step up my food chain, I might have, well, let's say the deer. And again, they only get 10%, so they'll have 600 calories. So let's say we go one more level up. We have our bears. They only have 60 calories. So you can see as we go up, the amount of energy goes from high to low. And then as we go up, the pyramid also gets smaller. So we go from having many organisms to few. And the reason why we have fewer bears in the forest than we have trees is simply because there's less energy for the bears than there are energy in all the trees. So there's a lot more energy at, say, the base of our food chain than at the top of our food chain. So as we travel up, we see fewer and fewer of those types of organisms. It's the same reason why you don't see a lot of lions in the savannah, but you might see lots of plants and trees and mice and grass, because at the bottom of that food chain are those plants, and those are the ones with a lot of energy stored in them, and as you go up, less and less of that energy. So just to review a simple question I might give you a pyramid and ask you to kind of just estimate the number of calories for every level in that food chain or in that pyramid. And I'll make up some numbers here. So I might make up 1,284 calories in my plants. Well, I'm going to ask you how many are in the second level, third level, fourth level, going up. And a simple way to do this is just 10%. So if you want to calculate 10% of anything, so let me say I give you a number like 1,284. All you have to do is move the decimal point one place to the left, and that's going to give you 10%. So in 1,284, the decimal point's right there at the end. All you have to do is move it one spot to the left. So now I have 128.4 calories. And then same thing, you're just going to move that decimal point one place to the left, so 128.4. Move that point over. I'm now going to have 12.84 calories. And then same thing, move that point one place over. I'll have 1.284 calories. And that's an easy way to calculate 10% going up your food chain, 10% getting passed on to each level. And just to remember, that other 90% is getting lost every level as heat. It's going away, but that 10% is what's getting carried on from one level to the next.